Hi guys, welcome to this video. This is one of the videos in the series where I talk or teach trigonometric graphs. This is for grade 11 and 12, but grade 10 people can also benefit because they're videos that have information that's useful to them. This will be a playlist or series. We'll have videos on explanations first, then later we'll look at past question papers. So if you're done with the content, you can go straight to the question paper videos. They're written question paper on them. The way to watch these videos is best when you can best watch these videos by trying the problems while you see them on the video, pausing the video and trying the problems, and then checking if the video will explain the same answer that you got when you tried the problem. So if I say I'm gonna draw a graph, you try drawing the graph first, and then see if it's the same as the one in the video. If there's a problem I'm trying to solve, you try to solve the problem first, see if it's the same. So please watch the video, and thank you for watching. Hi guys, in the last video I was showing you how to move from this to this. So in this video I'll be showing you how to move from this, from where you have to something like this. I have y is equal to maybe a sine x plus some value, where a and q are both not equal to 0. I'll be showing you how to add something, what the q has. So we've explored the effect of this, so we're just going to explore the effect of q. Now q is the vertical shift, the shift up or the shift down. This is what q represents. It represents a shift up or a shift down. So if you add a number, if you add a positive number, the graph will go up. If you subtract a number, the graph will go down. Let's see this in practice by sketching the graphs. Firstly, we will compare the graph of y is equal to sine theta and the graph of y is equal to sine theta plus 1. So let's draw the axis. If we draw the axis, we know that the graph of y is equal to sine theta is the mother graph. You should know how to draw this from watching the previous video. I will have it linked to somewhere on this video, probably at the top corner. If you know how to draw the sine graph, it goes something like this. Alright, this is the sine graph. When you've drawn the original sine graph, okay, let me extend this to go a bit higher. When you've drawn the sine graph, now you have to draw the graph of sine theta plus 1. There are two ways to do this. The first way is you draw a table, and your table has theta here, and you put the values of theta. So let's say this is 90, this is 180, this is 270, this is 360. So you put 90, you put 180, put 270, you put 360. You should start at 0, sorry. And then here you have y or sine theta. So you take, so we already know this, so we are looking at this. We already know sine theta, we are looking at sine theta plus 1. You take sine theta plus 1, you substitute 90, and you get an answer and put it here. Take sine theta plus 1, you substitute 180, you get an answer, you substitute here. You get sine theta plus this, you substitute this, and then you get all the numbers up to 360. What you'll get is, for 90 you will have 2, for 180 you have 1, For 270, you'll have 0. 360, you will have 1 for while you're substituting. So the first way you can use is substituting and then plotting according to your substitution. So when you plot, you would say where it's 90, okay, let's say this is 1 and this is 2 and this is -1. So if you're plotting, you would say where theta is 90, so theta is 90 all the way here, where theta is 90, y is 2, so y is 2. That's your point right there. Where theta is 0, you have to substitute that too, and if you substitute 0 there, you get 1. Where theta is 180, you get 1, so 180 corresponds with 1. The easy way, if you can't plot correctly, is just you draw the dotted line for all through 180, and then you draw a dotted line through 1. Where the lines meet, you put a point. Do the same thing for all the points, and then you connect the dots. That's the first way. The second way is to understand the concept, understand what happens when you add 1. As I said, when you add 1, you're shifting it up, but you're shifting it up 1 unit. What does that mean? It means the coordinate here, which was 0 and 0, is going to shift 1 unit upwards, and it's going to be here at 1. And the coordinate here, which was at 90 and 1, is going to shift up 1 unit. If you add 1 to 1, you're going to get 2. So it's going to be here. And the coordinate that was here, which is 180 and 0, is going to move up 1 unit, and it's going to be 1. Coordinate here was -1. You are adding 1 to -1, so it's going to be 0. Same thing here, it was 0, now it's going to be 1. And then you connect the dots. What I like to do when I draw a sine graph, because sometimes it's hard to get the shape right, just go to the maximum and the minimum, do something like this, and then that's the minimum. You draw this as well at the maximum, and then you come here to the center point, you draw something that looks like it's coming from there to there. So draw that, and then you go there, draw this, go there, you draw this, and now it's just a matter of like connecting everything. So you can move from here out to here, it's like that, and from here to here, it's like that, from here to here, it's that, from here to here, it's that. You get better at drawing the graphs the more you practice them. Yeah. Now, this is the graph of y is equal to sine theta plus 1. This is the graph of sine theta. The shape should look similar. It shouldn't look, this looks different than this, but it should be the same. It's because I use this method for drawing here, and here I draw freehand. Now let us go into sketching the graph of y is equal to 2 sine theta. So we are going to look at y is equal to 2 sine theta versus y is equal to 2 sine theta minus 1. Okay, for y is equal to 2 sine theta minus 1 and y is equal to 2 sine theta. Let's first draw this graph. This graph is going to look like the mother graph, except it's going to be at 2 and -2, the maximum. I'll link the video to where I talk about the amplitude. So the graph is going to look something like this. This is 360, 180, 270, 90 degrees. the maximum is 2, the minimum is -2, right? Now let's look at the effect of -1. You can do this method, but I'll explain the method of understanding the effect of -1. So if you understand the effect of -1, what's going to happen is, okay, let's put -1 here, let's put 1 here. -1 will shift this point 1 unit downwards, so this point will be here. -1 will shift this point 1 unit downwards, so it will move to here. -1 will shift this point 1 unit downwards, so it will be here. -1 will shift this point it will shift this point 1 unit downwards, so it will be here at -3. This point will shift 1 unit downwards, so it will be here. This is still at 360, this is still at 180, this is still at 270, and so on. Now you can do this and do this. Draw a line like so, draw a line from that, draw a line from that, and then now it's just connecting the lines. So you draw an arc here, draw an arc there, draw a straight line there, straight line there, straight line there, and then connect everything, connecting this, that, and that, that. So that is your graph of y is equal to 2 sine theta minus 1. This is the graph. Now let's go into sketching the graph of y is equal to negative sine theta plus 3. I won't compare it to y is equal to negative sine theta now. I'll just draw this one. So for this one, we have the axis. Again, you can draw it by drawing by getting the pair of coordinates on the square boxes, or you could understand what's happening with -3 and minus in front of the sine theta. Okay, so the negative in front of the sine theta means that this graph is not going like this, but rather it's starting from the bottom. But the amplitude is still 1 because the coefficient is -1 and the amplitude is the coefficient, but it's taken as positive. Okay, now that means this graph, the original one, went something like that, like this. But now this one has +3 here. We added 3, which means that every point will move up 3 units. So the point that was going to be here is going to shift up 3 units all the way up to somewhere there. And your minimum point, let me continue. The point that was going to be here, because it was going to go something like, it was going to go something like this. This point was going to be -1. If you add 3 to -1, it's going to be 2. So it's going to be there. This point was 0. If you add 3 to 0, it's going to go up to 3. This point was 1. We're adding 3 to 1. This is just 3. We're adding 3 to 1, so it's going to be 4. It's going up there. This was 0. Adding 3, it's going to be 3. So it's going to look something like that. This is your new graph. This is your center or line, whatever. So to see if you drew the right graph, the center line must have shifted 3 units upwards. And since this is 4 and this is 3, that means we're correct. This is 2. This should shift 3 units upwards, because this actually, it shifts the whole graph 3 units upwards, so the center should also shift 3 units upwards. Notice we have not shifted the graph anyway like this. We have not squeezed the graph. We have only made the graph go up and down. We are still going to go into videos for shifting left and right and squeezing and stretching, but now we have only done these. Now let us go into sketching the graph of y is equal to cos theta plus 2. It's the same thing. It's the same thing for cos as it is for sine. So we have this, which is the axis. Not such a great drawing, but this is the axis. The normal graph of cos goes something like this, but now we're adding 2, which means every point shifts up 2 units. Now think about the minimum. The minimum for the normal graph was going to be -1. The minimum now is going to go up by 2 units, so it's going to be go up by 1 and another unit, 2. The minimum will be there. This is a shorter way of doing it. The maximum was going to be at 1, but now the maximum must shift 2 units upward, so it's going to be, okay, sorry, this is 1, this is 2, this is 3. The maximum was going to be 1 for the original cosine graph, but now it's shifted 2 units upwards, so it's 1, 2. The maximum will be there. So you can sort of get a feel that the graph is already going to go like this before even filling in the rest, but you can fill in the rest just to get like a total sense of everything. We said this was the minimum, so there's another point that was going to be between the minimum and the maximum, which was going to be here at 0. Now it's going to be here at 2, and there's another point. So basically your graph is going to go something like this. That's your y is equal to cos theta plus 2. Once again, if you don't understand this, just go and draw the boxes, fill in your values, and plot the points, and then you will get the right thing, and then you can connect to the points if you don't understand this. But if you do, continue using it until you master it. Now let us go to the last one. The last one is, we look at y is equal to cos of negative cos theta minus 1. Negative cos theta minus 1. We know negative cos theta is something like this, but now we are subtracting 1 from negative cos theta. If you subtract 1 from negative cos theta, it's going to go down, it's going to shift down. So this point, okay, this was 90, this is 180, this is 360, this is 270. If you subtract 1, this 1, this minus 1, minus 2, 2, 0. If you subtract 1 from this graph, from cos theta, this will shift to here. This will shift down 1 unit to here. This will shift down 1 unit to here, because we're moving 1 unit down. 1 unit down from there to there. We're moving from there up 1 unit down to minus 1. From here to minus 2, 1 unit down. Now you've plotted your point. You can add more points if you want, but if you understand it, you don't need to add more. you can put your little arc right there. Okay, for cos the arc, you draw an arc like this, and here you draw an arc again, like a half arc. Here you draw another half arc, you draw a straight line, then you connect everything. Connect all these things. Alright, now this is your y is equal to minus cos theta minus 1. And we've reached the end of the video. Thank you. We've reached the end of the video. Thank you for watching. Please subscribe, tell your friends to come and watch. Leave recommendations on what I should do on the next video. Anything you need me to explain, any topic, any questions. Now I just want to talk to you guys about a few resources you can use. Firstly, we have the Desmos Calculator. It's a website online where you can write a formula for a function, and then the website will graph the function for you. You can use that to confirm your answers. So you can make up a trig graph, maybe an equation, try graphing it, and then go enter your graph into Desmos Calculator to compare it to yours, so you can see if you're correct. So there you can graph basically any graph you want. I'll leave the link to the Desmos Calculator in the description of the video. You also have the Science Smart Study Guide. I like this study guide. I like using it when I was doing matric. It has really compressed information. It has everything you need, but it doesn't have anything you don't need. So it only talks about something that will help you in your exam. It doesn't go around the corners and talk about useless stuff. I would recommend that. I'll leave the link in the description. If you want to use that, you have to go enter your name and your email, but it's not paid for. You just enter your details and they'll email you a link, and you go to your emails, press on the link, and then the file will download on your phone. It's a study guide. It's a really short, amazing study guide. And then you have chapter 1 trigonometry. This is a document. I don't know where I got it, but I'll make it available on my Google Drive. I'll leave the link in the description as well. You can go to that link and go download chapter 1 trigonometry. This one is for the math enthusiast. If you like maths, you can go use this. It's very detailed. It's amazing. I used this when I was in matric, and it has deep explanations. Well, not deep explanations, but it's detailed enough to let you know what happened. Then you also have past question papers. You can get past question papers from Stanmore Physics. You can get them from essay exam papers. You can get them from Department of Basic Education, and there are many more websites you can get past papers. You can use a lot of resources to study aside from this. The important thing is you just have to practice and practice and practice. Once again, thank you for watching. Please subscribe, like the video, share with your friend, turn on notifications. Whatever button you see at the bottom, just press it. Thank you.